All right, this is the test piece I'm using today, a double-sided T-joint. So I don't really know what you call it, but it's 4 joints. And I'm going to set it up in the Triangle Engineering test stand here and weld all 4 at different amperages using the Lincoln Power MIG 210 MP on stick mode. This machine does stick as well as lift arc DC TIG. And this is the way it steps you through the menu here. I'm selecting 1/8 diameter electrode. And instead of selecting 1/4 inch, I'm going to select 3/16 of an inch thick because I'm going vertical uphill, and I know that I'm not going to need the heat that it would recommend for flat or horizontal. So this is even a little hot, so we'll turn it down a little bit. Hot start and arc force are a couple of features on this machine that come in really handy. So we'll set it to 100, and you'll see it turns red. That's telling me I'm a little bit out of scope for a 1/8 electrode, as you will see here. It's keeping it lit, but it's just not really digging in and penetrating like you would want to see it. At least not in my opinion. There are certain applications where a bead like this at minimal heat might come into play. All right, 110 amps. This is starting to get a little bit better. Definitely better than 100 amps. Still probably not as hot as I would normally weld a joint like this going vertical up, but definitely easy to keep the rod lit and controllable. Easy to manipulate the metal. All right, let's chip that one off again and see what we got. Look at how it lights it up. That is pretty cool. Yeah, that one's a little bit better. The first one came out a little lumpy because every little movement when you're welding minimal amperage kind of makes it more of a lump. But things smooth out a little bit better if you can get things going pretty nice and hot. Now 120 amps here actually was borderline on this particular machine, borderline too hot. And it looks fine here, but every now and then I really had to jam it in there to keep things from falling out. When you start welding up toward the upper limit on vertical with 7018, oftentimes you start experiencing something called arc blow, and your rod starts burning at different rates and burning off unevenly and to one side. And so I had to keep it jammed in there to prevent that. So that came out probably the best of so far. And actually, I can tell that I don't want to go much higher than 120. So instead of going up to 130, I'm going to back off and try one at 105 amps. And after the fact, after I was all finished here, I kind of wished I had done one at 115 amps actually, but I didn't. And that's the way it goes. Always regret afterwards. I should have done this, or I could have done this. Sometimes I've just got to get the video done. 105 is not too bad. Controllable, keeping a nice tight arc. No problems with it sticking. Just doesn't look nearly as good as the 120 as far as the way things smoothed out. All right, now we're going to take this thing and cut it with a bandsaw right just about down the middle. And then take a flap disc and smooth out the sawtooth marks. This is about a 60 grit flap disc here. The thing about etching like this is the smoother you get it, the more toward a mirror finish you get it, the better delineation of weld metal versus base metal you get. Now this can be done using naval jelly rust remover. It can be done using concrete etch. Some versions of concrete etch will etch it, but I happen to just have some pretty strong it's a passivation solution for stainless steel. All right, let's take a look now at the puddle here at 100 amps, and then we're going to look at that nugget. So actually, even though it seemed pretty darn cold, it was penetrating in there, and that's the thing about stick welding versus MIG welding. We got the flux going on, and even when you think it's kind of cold, sometimes you're penetrating. 120 amps here. It looks like it's getting into that corner really well, and the etch reveals that it certainly was. Now I was having to do slight electrode manipulation there. Some tests don't allow electrode manipulation side to side, so sometimes you have to go a little bit lower heat. All right, let's take a look at the 105 amp bead here, and you can see there's some stuff going on down in the root of that joint that may or may not have got in there. That could have been me. Also, you see a little undercut right there. That was definitely me. So by taking a look at all of these, I think you can see why I think that 115 amps on this particular machine would have been just about right. All right, here are some important takeaways from this video, and one way of remembering it is the CLAMS acronym. I've said this before, but it bears repeating. CLAMS, okay? C is for current, L is for length of arc, A is for angle of the electrode, M is for manipulation of the electrode, and S is for speed of travel. Let's talk for a minute about current. For a 7018 1/8 rod, 3.2 millimeter rod, you could easily handle 140 amps flat or horizontal on a fillet weld like this. 140 amps would smoke it in there, would lay it in there, and the slag would peel off. But vertical uphill, you saw that 120 amps was, you know, getting close to the max. 115 probably would have been really easy to control and would get adequate penetration. So that's the current. You use less current for going vertical uphill than you do for flat or horizontal. Length of arc. Here's advice I give people all the time for stick welding. Set the machine hot enough that it won't stick when you hold a really tight arc, and then hold a really tight arc. Now, new machines are a little bit different than old machines. You saw on the Lincoln here today, that was an inverter machine, and so it's got something called arc control. What does arc control do? Well, arc control senses the length of your arc by a change in voltage. So when you get really close with the arc, your voltage drops. The machine automatically bumps the amperage up for you to prevent the rod from sticking. But you saw today 100 amps was about as low as I would want to go. I probably could have dropped down a little lower if I turned the arc control up high. I had it set on 3. Angle of rod. Now for a vertical joint like this, I always advise people to aim for as close to a 90-degree rod angle as you can, because when the helmet drops, you're automatically in the dark now, and you're going to, just by nature, you're going to gradually tilt upward and have a little bit of a push angle more than you think sometimes. So if in your mind's eye you're shooting for a straight 90 degree, you'll be in pretty good shape. M is for manipulation. So on a 7018 you don't really have to do any manipulation for a single pass fillet weld. I generally do a little bit just because the light changing directions kind of helps me see where I'm going and that kind of thing. Speed of travel. You got to go slow enough not to leave undercuts. So each time you, even if it's a subtle movement, when you're moving side to side, you need to pause at those toes. Toe of the weld is the edge of the weld. Pause there for a count so that you don't leave undercut. And also holding a tight arc goes a long way in preventing undercut. Arc blow. What's arc blow? You saw me reposition that ground clamp if you were paying close attention. I positioned the ground clamp on the plate where it was halfway up the plate. And the reason is, my thinking was on that was, sometimes people will advise you to position a ground clamp up top and weld to the ground. Some people advise you to clamp it down here and weld away from the ground. My thinking was, if I was grounded midway, I'd be welding to the ground, and then I'd be welding away from the ground the last half of the joint, and it might improve things, and it did seem to help. That's the advice though. On arc blow is kind of like witchcraft sometimes. It's hard to exactly determine what the cause is, so you just have to try different stuff. Move the ground to a different location usually has an effect. What's arc blow anyway? Well, arc blow is a magnetic forces getting set up from current passing through the metal, and they make the metal droplets deposit differently from the rod to the puddle, and it acts funny. So you'll be going along just fine, and toward the end of the rod or toward the end of the piece, you're like, what's going on? I got big balls coming off of here, whereas it was running really smoothly before, and you have to keep that rod really jammed in there to keep things from falling out on you. That's arc blow. It's not a good thing, and it happens especially a lot on small pieces when you're welding little test pieces and little practice pieces like I was doing today. So positioning that ground clamp midway seemed to help on that.